Hi, welcome to the second video for the Year 11 Chemistry Acids and Bases topic. This is subtopic 2, which is going to be reactions of acids and bases. So the reason I've got this GIF playing here that you can see on the screen, this is from a titration, and this is something that we do a lot of with acids and bases, and you can see here the color change that occurs with an indicator. So we're going to get to that in a bit later, but hopefully sort of piques your interest for really doing some chemistry with acids and bases. So in the last video I talked about the general reaction for acids and bases, which is this top pink one here, which is an acid plus a base gives you a salt plus water. Now there's a couple of different reactions you can do here. Acids and carbonates. A carbonate is just another form of a base, but it also has a carbon dioxide in there, which can be given off in the reaction. A bicarbonate, same thing, it's just HCO3 minus instead of CO3, 2 minus is what your carbonate is. But in both of those you still get salt plus water, and then you get carbon dioxide thrown in as well. You can also have a reaction between acids and metals. Acids and metals will still give you a salt, okay? But instead of getting water, you just get hydrogen gas, and that's basically because you're missing the anion part of the base that you'd normally have, okay? So just going to go through and show you a couple of those. Alright, so generally when we're referring to acids and bases, we talk about them neutralizing each other. Now that refers to that acids have a pH below 7 and bases have a pH above 7. So when they come together, alright, in equal molar quantities, you can actually neutralize them and get a pH of 7, which is neutral. That's why we call it neutralization reactions. So this reaction is exothermic. That means it releases heat. Okay, so really important to know because they can generate a lot of heat. Okay, really good example is when an acid can dissolve in water, react with water. The water is actually acting as a base there. If you don't have enough water, this can actually be quite an explosive reaction. Okay, because it generates a lot of heat. Okay, so you need enough water there to be able to absorb that heat and that energy that's given out. So those equations I showed you on the previous one, I've got some examples here. So we've got an acid plus a metal oxide. Okay, so this is in a sense it's still just a base because metal oxides are basic. So we still get a salt plus water. Okay, so the hydrochloric acid here donates a proton, it gets picked up over here by the oxygen to form water, and we get our salt over here. Acid plus a hydroxide, we've got sulfuric acid and sodium hydroxide to give us sodium sulfate, so again salt plus water. Here's our carbonate one, again we get a salt and some carbon dioxide this time, but still water. And this last one, which I'll just move me up here, alright, is a hydrogen carbonate, which is a bicarbonate. So a bicarbonate is this one, HCO3 minus. So again, acid plus bicarbonate gives you salt plus water plus carbon dioxide. So acid-base reactions are pretty straightforward. If you just remember salt and water, and if you hear the term carbonate somewhere in the name, you're going to get carbon dioxide as well. But we can write those as ionic equations. So what they look at is like this. So I'm not sure if you might want to have a look at the previous slide and compare the two. For this acid plus metal oxide, it comes back to that definition in the last video, that an acid is a proton donor and a base is a proton acceptor. So realistically what's happening each time is that we've got a H plus being donated, a base picking it up, and we're forming water. So we talked about this in the previous one as well. So just showing you as an example again, in the carbonate one we're still getting our water forming as well, same with the bicarbonate one. These equations are still balanced. All we're doing is leaving out the spectator ions. They are the ones that are the anions generally off of the acid, okay, and the cation off of the base, because it doesn't matter what they are, they just form our salt. The acid-base reaction still occurs here, and they are balanced. If you notice, I'm just going to pick this carbonate one here. We've got the same number of hydrogens on this side as we do over here, so 2 and 2, same number of carbons, same number of oxygens, but the charge also balances. A 2 plus here and a 2 minus here will cancel out to give us no charge, and on this side we've got no charge. So you must have, in ionic equations, you must have the charge balancing and the atoms balancing as well. Now, acidic oxides are ones made from non-metals. So this little GIF I've got showing here is actually having some dry ice, which is carbon dioxide, dissolving in water. Now, if we had an indicator in this, it would actually show us that we would go one of those hotter colors, so probably a pink or a red or a yellow color, okay? That's because carbon dioxide dissolving in water will give us carbonic acid, which is this one here, H2CO3, which is acidic, okay? So non-metal oxides are acidic. So easy way to think about this to remember it is just think about some of the acids you know. sulfuric acid, nitric acid, hydrochloric acid. You've got sulfur, nitrogen, chlorine there. They're all non-metals, okay? So non-metal oxides are acidic, okay? So here's some examples of some of the different ones, and these are how they form. So we've got carbonic acid here, sulfurous acid, sulfuric acid, and phosphoric acid. All of them non-metal oxides, all of them are acidic. Basic oxides, on the other hand, are oxides of metals. So this little GIF that I've got going here, this is actually sodium metal, which has been dropped into some water, and you can actually see in here, just on the surface of the sodium, if you look really closely, you actually see a bit of a blue color. So you can actually see that it is basic in there. It's got some indicator in that that's been put in. So yeah, this reaction is forming something that is basic. So again, think about the most common base you would use in the lab would be sodium hydroxide. So if you think about that, it's got a metal in it. Metal oxides are basic. When they react with water, they form alkaline solutions. They're alkaline solutions as water-soluble bases. Okay, so again, got some examples of it here. I've got sodium oxide reacting with water to form sodium hydroxide, and I've got potassium oxide forming potassium hydroxide, and quicklime, which is calcium oxide, forming slaked lime, which is calcium hydroxide. Okay, that's actually insoluble calcium hydroxide. Forms this like milky solution. So in all of those, you still get hydrogen gas being formed as well for the first two, and that's kind of like a two-step process. So when you add your metal into the water, like sodium or potassium, it starts fizzing around. What happens is two-step process. The sodium ion goes in, so sodium metal goes in and it forms sodium oxide in solution that then goes on to form sodium hydroxide, and it releases hydrogen gas. It's quite a vigorous reaction. If you've done this before with anything bigger than just a small rock-sized piece, you probably get a good bit of flame and an explosion that occurs out of it as well. It releases a lot of energy, so you have to be very careful. Alright, so that's just a quick introduction to some of the different reactions that acids and bases can undergo. The next topic we're going to be looking at is going to be looking at the pH scale and how we do some pH calculations as well. So hopefully this has been pretty straightforward. You might just, best way to learn these is just to practice. You can write down the general equation they got. So acid plus base gives you salt plus water, or acid plus carbonate gives you salt plus water plus carbon dioxide, and then practice doing some. If you need any help or got any questions, comment down below. Please hit subscribe if you haven't done so already. Stay safe, and I'll see you in the next episode. Thanks, guys.